Today we're doing a demonstration for DC Water. We're demonstrating our leak detection and condition assessment services.
The city is very, very old. We have some water mains that were put in service in 1858 that are still in service. The average pipe life right now is 77 years, and we are in the process of increasing our capital improvement program. Where we're trying to replace approximately about 1% of our pipe each year.
Acoustic-based condition assessment and leak detection is very important for today's municipalities because it's non-destructive, it's non-intrusive, and it's a much easier way to assess the condition of a pipe without actually digging down to the pipe and taking out a sample, which costs lots of money and is very intrusive, shuts down roads. We feel this is very important in today's municipalities because money is tight and people don't want to spend money in the wrong place. So using acoustic condition assessment technology can help municipalities prioritize where they want to spend their money. For this demonstration, we're going to be testing this main, which was installed in, I think, 1974, or 1874 actually, it's much older than that. Cast iron main, and we're going to be demonstrating two things, is the ability to find leaks on cast iron mains like that, and also the ability to assess the condition of the pipe using our technology. So we're using our standard Leak Finder RT system here with sort of a specialized software package to do condition assessment. And right here we're standing beside the blue transmitter station. And so if you guys have used correlators before, it's very similar type system to that, where you set up two stations. We've got a blue station set up here, the white station set up down on the other side of the street there. And this is just a magnetic sensor which is lowered down onto the top of the valve. And so this will attach to any sort of ferrous piece of pipe material. Sometimes the tops of the valves have little brass nuts on them. It doesn't grab onto that, so we're going on the side of the valve here. But as long as you get a good solid magnetic connection, that's enough for the system to work. And I can feel that it's got a nice magnetic attachment there. It's got a lot of pull from the magnet there, and I just hit the green button on the transmitter, and then this is good to go. So these two transmitters, the blue and the white transmitter, they transmit this vibration signal back to a central receiver, and that's what we have set up in the back of the car over there. And the central receiver feeds everything into a computer where we got a software program that does all the analysis for us. Okay, so the purpose of this first test that we're going to do is to simulate the ability of the Leak Finder RT to actually locate a leak. And then the next test we're going to do condition assessment. And so what we have is over here is we have a fire hydrant flowing, which is in between our two sensors. Our sensor spacing is approximately 510 feet, which we measured with a measuring wheel. And we have the hydrant flowing, I would probably guess at between 5 and 10 gallons per minute at the moment. And we can see here on the software that a clean spike is showing up approximately 22 feet from the blue station. And so this spike represents the position of a leak on the main. So if you were to go out there and just run a background test and see a spike like this without a hydrant flowing, then you know you've got a leak, something that you have to go and repair. Okay, so what we have here is just a diffuser we're putting on the fire hydrant. We're using this to introduce noise into the pipe for the purpose of doing a velocity test. So our sensors are over there on Marion Street right now. And the sound that we're introducing here is going to travel down this pipe and then to Marion Street and then down Marion Street. And we're going to measure how fast that sound's traveling down the pipe. We just recorded the velocity of sound in this section of pipe and went through and did the calculations on the final number. And we measure a velocity between about 3850 and 3950 feet per second. And now, so we're going to go back to the office and refine that file to make sure we end up with the final number. But on rough calculation, that puts between about 0.3 and 0.4 inches remaining wall thickness on this pipe. So this value, like I mentioned before, does not include the thickness of tuberculation. So you do have buildup of tuberculation on the inside. This number actually represents the structural stiffness, the structural thickness of the cast iron remaining. It doesn't include the soft material on the inside. Okay, Kurt, so we're just wrapping up testing here here on this main. This is 1943 installation? 1947 installation, cast iron main. The condition assessment results show that it's approximately 0.5 inches remaining wall thickness. And in comparison to the previous main we tested, which was installed in 1874, that one had a wall thickness of 0.35 inches. So this one obviously in a little bit better condition. So as we were talking about before, maybe the soils here aren't quite as aggressive as over there, or maybe it's just because the age of the pipe. This is 50 years younger, this pipe over here, so it had less time to degrade. Our equipment, our condition assessment offering is 100% non-intrusive and non-destructive. So we can offer leak detection testing and condition assessment results all at the same time without actually shutting off any water or putting anything inside the pipe.
It gives us an extra tool to prioritize the water mains. We have a grading system that we're using to try to determine which pipes to replace, and then once we come up with what we want, we could use this information to see, is the pipe still in good shape? If it is, then maybe we should go to another pipe that is in more critical condition.